Yeah. We will discuss now the heat load calculation formulas. Okay. See, basically, as I said before, okay, our aim is to prepare the thermal load calculation for the particular building, right?
Yeah.
Say, for example, any of the spaces or bedroom or any of the space, you are going to do the thermal load calculation. You are going to find out what is the total heat inside the space, right?
Yeah.
Okay.
What is the
So
total
now,
heat to be removed?
yeah, fine. So now, when you are going to calculate what is the total heat inside, basically, say for example, the heat comes from the glass, from the wall, or through the say for example
Roof
through the roof partitions, through
and
the
inside
ceiling, yeah, through
equipments.
the infiltrations,
Even,
right? Through
yeah.
the through the ventilation air, outside air,
Yeah.
through the
Mm,
people, okay, through the kitchen appliances, through the
yeah.
electrical equipments, through the motors, or through lights, right? So this
Yeah.
is basically these are the equations. Okay. So what I said before, I ask you to study the psychometric chart. I ask you to study the sensible load,
Yeah.
heat. Okay. I ask you to study the latent heat.
Mm,
Then after that, I ask you to study the ASHRAE weather properties, right?
yeah.
Okay. So these are the things. These are the things I ask you to study, right?
Yeah.
Okay. See. Okay. See now, for example, whenever you are going to do the calculations, we are going to study some basics. Just check the WhatsApp now, please. Okay. We are going to study some basics. Okay. So
Okay.
that basics is based on the sensible load and latent load, right? So whenever you do the calculations, you should understand what is a sensible load and what is a latent load, right?
Yeah.
Okay. Remember, I have shared one video, one lecture, one professor. He took the videos, right?
Mm,
He told you about what is a complete sensible load and latent heat. Maybe I can share it again once again. Okay, for you to
yeah.
watch it. Okay. See, for example, this is the equation. Q is nothing but U A delta T, right?
Yeah.
So
UA delta T.
this equation from where it came, that lecture it is given very completely, right? So
Okay.
how this value, how this equation came, U A delta T. What is the area? What is that U? Right? Is the
Mm,
rate of heat transfer through a
uh,
partition, and what is
yeah.
the delta T temperature? Okay. So this
Difference in
equation we
temperature.
have studied. I have shared one lecture for each and
Mm,
every equations. Okay. For example, UA
yeah.
delta T is here, and if when you go this one, Q equal
Mm,
MCP delta T, for example, okay,
mm,
it's a sensible load equations. So that type of equation you are going to study. Say, for example, when you have the heat gain through the ventilation air, there is a
mm,
sensible load plus latent load, right?
yeah.
So that
Both
is the
moisture.
equations. So that is the equations. So say, for example, when you have a HAP software, okay, in the HAP software, you are going to enter all the values, right?
Mm, yeah.
So then you will get the result, right?
Mm, mm.
Okay, so that result, how it is calculated? What is the equations? What is the equation behind that? Okay,
Okay.
that
Okay. What is
equation
the
came from,
formula? The program
yeah,
behind that?
yeah, the program behind that. So that understanding
Yeah.
you will get it from here, right?
Yeah. Yes.
Okay, so this came from where I'm saying some equations, and where is the standard? Okay, that standard is this one, ASHRAE fundamental, right? You can say residential cooling and heating load calculations. Okay, this is from ASHRAE fundamental. Okay, so when you go further down for ASHRAE fundamental, can you see
You are
equations?
sharing something. Actually, I cannot see anything here.
Okay,
Only
okay, okay. Yeah, let me share. Let me share my screen as well. Okay.
mm,
Okay. So what I was explaining you before, this equations, right?
yeah.
This heat load calculation equations. Okay.
Mm,
So here you can see whatever the equation, heat transfer rate. Okay,
mm,
the rate of heat transfer through a material or structure. Okay, and difference between indoor and outdoor temperature. So this is the basic equation. Okay,
mm.
so based on this
Okay.
equation only, we are going to calculate heat drain through the glass, heat gain
Heat
through the
drain
wall,
through the wall.
heat gain through the partition,
But,
heat gain through roof, heat gain through ceiling or floor, infiltration. So the infiltration, each and every, what are the type
mm,
of heat? You have a sensible heat and you have a latent heat,
let
right?
me do. Mm,
So if you go to the psychometric chart, what I told you to read, psychometric guideline, in that it is
mm,
given here what is a sensible load and what is a latent load. That clear definition, right?
mm, mm.
So if you
Yeah.
go to the psychometric chart, when you have a psychometric chart here, okay. So when you heat something, the line will go from x from the say for example through the x-axis, right?
Yeah, dry bulb temperature we have
Yeah,
in the
yeah,
x-axis.
through the diable temperature. So that is a sensible load, because when you say sensible load, it is just you are increasing the
Dry.
temperature, heat.
Yeah, yeah.
Okay,
Just
when you
dry
say
heat.
latent temperature, you change the conditions,
Water
like
vapor.
from state to from one state to another state, right?
Yes. Yeah.
Change in state basically. So that is a latent load. So that understanding you will get it from the psychometric chart.
Okay.
So that is what I told you, to study the psychometric chart first before you go to the thermal load calculation, right?
Yeah.
Okay. Now these all you have a different equations. You have a ventilation air, you have a outside air, through the people, through the kitchen appliances. So these all come from where? Based on the fundamental 2000, say 21 hash rate HVAC fundamental or before, right?
Mm.
Clear, right? What I'm saying?
Yeah. Clear. Yeah. Clear.
Okay. So now when you go to this particular guideline, you may see the same type of equations here. Say for example, can you see this one?
QT QS plus sensible plus latent heat load.
Yeah, latent load, right? So here you will find out all the definitions here.
Yeah.
Okay, and what is sensible load? You have equation here. Okay, and what is the latent load? You have equation here.
Mm.
So this is what we did. This is what we have a say for example, this sheet give you the summary, like for whatever the whatever the ASHRAE, this give you the summary. Okay, say for example, if you go further down, okay, there are some other equations. Okay, can you see one equation for the air change hour, right? You are going to calculate the infiltration air flow rate through based on the air changes per hour, right?
Okay. Yeah.
Okay, so that equation also you will come across when you do the thermal load calculation through the HAP software. Okay.
Okay.
Okay, so that is what so this is the basic understanding. If you read this particular chapter 17, okay, your next
Chapter
assignment,
17.
just go through the chapter 17. Just go through as a, no need to remind anything, okay, because you have already the book you have, but just read. You understand what is available in this guideline, right?
Yeah.
Unless you see, you don't know what is there here, right? Say for example, if you go to say for example,
This
okay,
chapter
here
17 of ASHRAE, right?
yeah, chapter 17 of ASHRAE fundamental. Okay, so here there is the equation here. Okay, and if you go further down, there is a combined ventilation and infiltration flow. So what is the equation here, right? Okay, say for example, sometime you may take air from outside and you may take air from returner side and you will mix it before enter into the coil, right? So that is a mixing of air.
Mixing of air.
Yeah, so that understanding you will get it from here. See, for example, here there is equation, right? Okay, and you will find out there is equation here for slab flows. Can you see slab flow?
Okay, slab floors. Oh, okay.
Okay, so this is what whenever you do the ground floor calculations, right? Your slab on grade, so that equations. Okay, clear?
Yeah. Fenestration.
Yeah, here you can see infiltration and ventilation, internal heat gain.
Occupants, lightning,
Yeah,
appliance.
you can see the total latent load. What is the equation for the total latent load?
Outdoor air plus.
Yeah, you have a different directions, northeast, northwest. Okay, what is this latitude? Okay, and what is the shade line factors?
What is that shade line factors means?
It is for glass.
Okay.
Okay. See, when you have exposure, say for example, you have exposure, right?
Yeah.
So that exposure through the material, like whenever you have a the say for example, assume that you have wall, right? Okay, so your depends upon the direction. Say for example, it is not that your solar direction in one side of the building, right? You have 4 walls, okay, but your solar will not be in all the 4 walls, right?
Yeah.
Okay, so that is a fact. Yeah, it will be in particular direction. Say for example, from east to west, you have a particular directions, right?
Yeah.
So that factor, okay. And when you have inclined building, okay, it is not that 100%. You have some factor. So that shading basically. So this all it is there in the HAP software. Okay, it's already feeded, but we are going to understand what is the behind. Okay, how when you do the app software, what is the basis? What is the basis? Okay, so that you will try to understand. You can able to read this. What is the heating load? What is the equations? Right, the heating load factor, BTU per hour per square feet. Okay, so ventilation and infiltration. Can you see here all the equations? Whatever we have
Yeah.
seen that equations in that particular
Yes, no.
guideline. Can you see exterior A into CF UA? Okay, exterior and occupant and appliances. This is occupant calculations. But here it is given in very simple method. Say for example, if you go to appliances, what is the equation? Heat gain BTU per hour is nothing but power of the appliances in watts multiplied by 3.413 will give you what is the heat gain through the kitchen appliances. This equation is very simple equation, but came from ASHRAE. Sometime it will be complicated, but you can able to understand some basics, right?
Yeah.
There is some humidification. Okay, the load calculation equations. You can see that equation here. Exterior surface above grade Q equal to UA delta T, right?
30. Yeah.
Then partition UA delta T.
Condition buffers.
Total sensible load, right?
Sum of all the loads. Sorry.
All the loads, yeah, all the loads. That is a total sensible load. Similarly, you have a latent load as well. So you have to calculate the latent load. Okay. So what is the where the, remember I told you to study the external load and internal load, right?
Yeah.
So in the internal load you have a lighting. Say for example you have a lights. So light is purely sensible load.
Sensible load. Yes.
So when it comes to the ventilation air, you have a sensible and you have a latent.
Yeah.
Right.
Yes. And we have what you call it. But the appliances, in some appliances we will have latent load also, right?
Latent load also, yes. Whenever it comes to the moisture, there is a latent load, right?
Latent. Yeah.
Okay. See, for example, this is the example house, how they calculate the heat load calculations, how they are calculating. This is just example. Okay. Infiltration, this is example here. Okay. So if you go through the chapter 17, you will get some basis. Okay. How when you work in thermal load calculations, you will have a basic understanding, right? Okay. There are different equations here. Yeah.
Subscripts.
Okay. And also chapter 18 for the non-residential cooling and heating load appliances. One for residential and one for the non-residential. So there is some difference, but not exactly the same. Not exactly, it's not a major difference, as I say. Okay. You can see the people lighting.
Yeah, the type of load varies between those.
Yeah, because there is an industrial type, right? The industrial you have a different type of equipments. When you talk about residential, it is only for human comfort. When you talk about non-residential, it is for that particular comfort, right?
Yeah, working and the industry type.
Yeah, industrial type. Say for example, you have a audience seating area, okay, locker room, okay, lighting power densities. Remember when you calculate the lighting, what is the lighting power densities for that particular area? What is required? Okay, so that you can get it from this particular ASHRAE, right? Okay. Then when you go further down, this is a non-residential cooling load calculations. Okay, you have a heat for the motor horsepower. Okay, what is the heat dissipation for the motor? That equation is here. Electric motors, you have equations. Okay, and appliances. Okay, then you have a.
It was there, right, in the summary, like you were showing.
Yeah, this is a summary. See, this is a summary, but to get the idea from where it came, you have ASHRAE, right? Okay, so just go through this particular chapter 15, 16, try to understand from your side and go through the psychometric chart, go through the ASHRAE parameters, get familiar with this one, then we can able to do the half thermal load calculations. Okay, so when I do the half thermal load calculation, you have a basic understanding. When I say something, you know that where it came from, right?
Yes.
Okay, just can you start practicing this particular week, chapter 15, 16, and also psychometric chart?
No, it's you said it's 17, 18, right? The fundamentals.
Yeah, chapter 17, 18. Then chapter 5 again, the SOFAT
Okay,
regulations.
the SAFAT regulation. Okay.
That regulation, it came from here only. It's not, it's
They were
extracted from
referring.
ASHRAE.
Yeah, they were refer to the ASHRAE and refer to the
ASHRAE. Yes.
district.
Then they prepare based on the local to match with the local requirements, right?
Yeah. Okay.
Okay. So just to study this for 1 week. Then after that, I will tell you how to install HAP software in your PC and how
Okay.
to do the thermal load calculation, how to get the result, right?
Okay. Yeah.
Okay. Have you installed HAP software in your PC?
No, actually, this is my company system. I can't do anything. Next week, I'll bring my what do you call my personal PC, so we can install that there.
Okay. Okay. Understand. Okay.
Yeah.
Yeah.
And
So
one,
yeah, tell me, you have any doubts?
yeah, I have the doubts regarding that psychometry chart. Like you
Yeah.
were
Yeah.
asking
Yeah.
the specific volume and everything.
Yes.
Because
Yes.
mm,
Yeah. If you go to my guideline, okay, psychometric calculations, design guide. Okay. Okay. If I go to say from, for example, carrier, right?
yeah.
Can you see this particular?
1 minute. Yeah. Okay. From.
Can you see this is the dry bulb temperature? This is the wet bulb temperature.
Yeah.
If you extend, this is the enthalpy. If
Okay.
if you extend this line, this is a dew point temperature.
Okay.
When you have a dew point temperature, you have a both dry bulb temperature and wet bulb temperature will be the same temperature.
Okay. Actually, in that
Okay.
in the one which I was referring, it was simplified, and those the outer scales were not there. The dew point temperature.
Yeah. Then after that, you have a relative humidity. Then you have a specific volume, right?
Okay.
Standard specific humidity. So why we require this one? Whenever we do the calculations, we will refer the psychometric chart to find out the other values. When you know two value, you can able to find out other values,
Other
right?
values. Okay.
Say for example, you want to calculate a sensible load, right?
Okay.
You want to say for example, QA MCP delta T. Okay.
Okay. Okay.
So say for example, you have a different temperature, right? You have a two temperature.
Yeah.
Okay.
Okay.
One
The
temperature here
output
and
will
one
be.
temperature here, right?
Yeah.
Okay. So this is the
Okay.
sensible load. Remember, you might have seen before, right?
Yeah.
Okay.
What
Now
is
you are
this
going to
like?
calculate the latent load. Okay, latent load. So latent
Okay.
load based on these two temperature, you should know what is the specific humidity, right?
Okay.
So
So, for
based on
example,
that,
like.
yeah, based on that temperature, you can able to calculate what is the specific. Say for example, if you go to this particular equations, can you see this equation? Latent heat gain.
In,
Okay. Yeah. Which one I will take for example? Okay, if I go to this particular ASHRAE, see this is the equation for the lighting. Okay.
okay.
So there is a heat transfer equation. Okay. Yeah. Here, can you see this one? This particular from the internet. What is that they given for the to calculate the latent load? CFM multiplied by 4.5 multiplied by delta H. Right? Clear? Okay. So this delta H is taken from the psychometric chart. Okay. You can see that this is the psychometric chart. You can see the delta H. Okay. The delta H is the difference in specific humidity. Clear, right? Okay, so this is the way you find out your total load. Okay, based on you can see the ASHRAE, you will find sensible load plus latent load is nothing but the total load. So you have a sensible load equations and then you have a latent load equations. So by using this ASHRAE fundamental, you can able to calculate what is the total load. Okay, for either for the people or for the ventilation air, outside air, infiltration air, or for the lighting or envelope, any envelope or glass, you can able to calculate. Clear, right?